Hey guys, today we're going to talk about lines. Hopefully this is a review, but we're going to review the two types of equations that we're going to need in this section of equations of lines, and we're going to talk about how to write them and also a little bit of how to graph them, so a little bit of two different things. Really, there's only two forms you need today, and those are written right here. The two forms are the slope-intercept form, which most of you guys are the most familiar with, and then point-slope form, which will be pretty handy as well. So a couple things about the slope-intercept form. Please remember that this right here, m is the slope, okay? B is the y-intercept. And what does it mean to be a y-intercept? Well, a y-intercept is where it hits the x-axis. And if you don't know that, make sure you write that down. So if I give you an example here, I could say, what's the slope of this equation? So you'd say the slope is 4. So the slope equals 4, and the y-intercept of this problem would be -7. So if I was asking you to graph this equation, which you could do really quickly, you'd have your grid, okay? Then I always start at the y-intercept. So the y-intercept was -7, so I'm going to go down -7 and plot a point. Okay. And then my slope tells me I'm going to go up 4 and over 1. So I'm going to go up 4, 1, 2, 3, 4, over 1, and plot a point. Now I might do it again, up 1, 2, 3, 4, and then over 1 again. And then I could draw my line through that. And of course, you want to just do it the best you can. Make sure you have arrows at the end. So it's going to look something similar to this. Okay, and that would be my equation. So slope and y-intercept, very, very handy, hopefully really easy to use. The other equation is the point-slope form, and when are you going to use this? Well, when you have a point and you have a slope. That's the easiest way to remember it. So I showed you what this looks like here. So in this case, my point that I would have gotten plugged in would have been, and this was always the opposite. So here's the x value, here's the y value. We always change the sign. So the point for this would have been -3, +2, because the x's and y's change signs. Okay, and then the slope for this one would have been 8. So if I wanted to graph this, just like the other one, I could have plotted my point. So the point -3, 2. So 1, 2, 3, up 2. So here's my point, and my slope tells me I'm going to go up 8 over 1. Or I could go down 8 to the left 1. It's up to you. So 1, 2, 3, 4, 5, 6, 7, 8, and over 1. So my line would have looked something similar to this. Okay, so a pretty steep slope with your arrows at the end. So when you're trying to determine what the point is, if it's in the equation already, when you take it out, the signs have to change. Okay, so now we're just going to practice using these, writing some equations, and then we'll do a story problem, and then we'll be done. So here's the first one. It says you're going to write an equation in slope-intercept form. So just as a reminder, slope-intercept form looks like this. That has a slope of 3 and a y-intercept of -2, and then you're going to graph it. So all I have to do is plug these in. So slope was the m, okay, and the y-intercept is the b. So all I have to do is plug in. So I'd have y equals, m was 3, and then x, and then b was -2. So there's my equation. And then I just have to graph it. So remember, we start at the y-intercept, so that means where it hits the y-axis, which is at -2. And then the slope tells us to go up 3, 1, 2, 3, and over 1. And then up 3, 1, 2, 3, over 1. And I'd plot a couple points. The more points you have, the more accurate your graph will be. 2, 3, over 1. Okay, so something like that. And then, of course, you can draw your line through. So there's your line. And always put arrows on these if needed. Right, and that's it. So slope-intercept form should be really easy. Basically, just plug in the numbers and then plot your points. Now, point-slope form has a little bit more work to it. So point-slope form, it says, remember, point-slope form looks like this. Y minus y1 equals m times x minus x1. And you're going to want to know that. Okay. It says the slope is -3/4, so that's your m. And then here's your point. So this is going to be the x1 and the y1. So you're going to plug in a -2 and a 5 into your equation. So when we do that, we'd have y minus our y value, so minus the 5, equals our slope, which was -3/4, and then in parentheses x minus the x value, so minus a negative. So notice there's two negatives here. Two negatives always turn into a positive. So we could rewrite this as y minus 5 equals negative 3/4. And then instead of x minus negative 2, I can change it to x plus 2. So notice when I look at this equation, my 5 was positive, now it's negative. My negative 2 was negative, now it's positive. So the x's and y's change signs. So there's your equation. And then if I ask you to graph this, you just have to plot the point and use the slope. So my point was negative 2, 5. So go to the point negative 2, positive 5. Plot your point. And then it says your slope was down 3 over 4. So I'm going to go down 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. And then maybe down 3 again, 1, 2, 3, and then over 4, 1, 2, 3, 4. We've got a couple points, and then we can connect our line, just like that. And then, of course, add your arrows. And that's it. All right, so if you have questions about point slope form, make sure you ask. But if they give you a slope and they give you a point, you're just plugging them in. Okay. Here's one more that has a little bit more work to it. So this one says you're going to write an equation of the line through these 2 points. But here's the problem. We don't have an equation form for point-point lines. Okay, we only have slope-intercept or we have point-slope. So we need to find in both of these the slope. So we should remember from the last section how to find slope. Remember, slope is y2 minus y1 over x2 minus x1. So we're going to start by finding slope. So when I do that, I'd have that m is equal to, well, here's x1 and y1, here's x2 and y2. So we'd have 10 minus 4, so y2 minus y1, over, my x2 was 8, my y1, or x1 was negative 2, so minus negative 2. And now I can go ahead and simplify. 10 minus 4 is 6. 8 minus a negative, those become pluses, equals 10. And always make sure you reduce your fractions. So 6 and 10 can both be divided by 2, so we get 3/5. So there's my slope, and now I can use point slope form because I have a slope now, and I have a point, and I can use either of them, and I'm just going to plug them into my equation. So I'm going to use negative 2, 4. Okay, you could use either one you want, it doesn't matter. So in step 2, I'm going to say y minus the y value, so minus the 4, is equal to my slope, which we just found, and then x minus the x value. And now we can simplify. Typically, if it doesn't specify the form, put it in slope-intercept. So I need to simplify this. So 2 negatives make a positive. And then I need to distribute my 3/5. So I'll have y minus 4 equals 3/5 x plus, well, 3/5 times 2 is 6/5. And then my very last step is to add the 4 over, because we want it to be in slope-intercept form. So we'd have y equals 3/5 x. And then all you have to do is add 4 to 6/5. Well, 6/5 is the same as 1 and 1/5. So if I add 4 plus 1 and 1/5, I get plus 5 and 1/5. So there's my equation. Okay, so if it doesn't tell you to leave it in point slope form, make sure you change it to slope-intercept form. That's really important. Okay. So what the heck do I do if my slope is 0? Okay, well, you got to think about this. What kind of line do 0 slopes fit on? Okay, well, a 0 slope means we're not going up or down. So in a graph, that means we're going to be going horizontally. So if I want to graph a horizontal line, it might look something like this. I'm just going to draw mine dotted to start. Okay. So here's a horizontal line, and maybe it hits at -2. So this is a 0 slope. Okay, I'm not going up or down. So in this case, I just have to write an equation of a horizontal line. Well, these are really easy. What's the only axis that a horizontal line hits? Well, here's the x, and here's the y. So it only hits the y-axis at this point right here. So I just have to write y equals, and whatever that y value is. In this case, it's -2. So -2. So anytime you have a 0 slope, it's going to be y equals a number, and that's it. Really short, really simple. So the same concept applies to slopes that are undefined. Well, what kind of lines have undefined slopes? Well, those are ones that go straight up and down. So that might look something like this. Okay, so straight up and down, think of the wall that we can't walk up. So here, which axis is this line hitting? Well, it's hitting the x-axis. So let's say this is at 1, 2, 3, 4. So it hits at x equals 4. So then my equation would just be x equals 4. So these are, anytime the slope is 0 or undefined, you're just going to have y equals something or x equals something. Really short, no other variables, just one in the whole equation. Okay? And these answers can be positive or negative, so be really careful with those. Now, we're going to do this story problem and then we'll be good to go. So here, it's a good application problem. It says an apartment complex charges $525 per month plus a $750 annual maintenance fee. So in part A, it says write an equation to represent the total first year's cost in terms of months. So if we're going to set up an equation for this, we need some variables. The first might be the total cost. So C equals the total cost. And maybe we say M equals the number of months. So you always want to start off by writing your two variables. So now we have to write an equation. If we're going to write an equation using these two variables, we have to think about which one is going to be a set cost and which one's going to be a monthly cost. Well, if you look here, it says $525 per month. So think of that as what it's increasing by every month. So that's going to be considered your slope. Okay, and your one-time cost or your annual fee, this is going to be your y-intercept. Okay, so if it's a one-time fee, you only have to use it as a y-intercept. So now we can just plug into our formula. So C is our total, okay, and then equals our slope, which is the 525 every month. Okay, well, M represented our month, and then plus the one-time fee of 750. So slope per month, okay, or amount per month, plus the one-time fee. And now we're done. So this is the equation for the first apartment complex. And then it says, compare this rental cost to a complex which charges $200 maintenance fee, but $600 per month. So we need to write a new equation. We can use the same variables. So C is our total cost. What's the monthly cost? Well, that's the 600. So $600 per month, plus the one-time fee of the maintenance, okay, which is 200. So now we have two equations, and it says if a person wants to stay in exactly 1 year at the complex, okay, so this is important, 1 year, which of these two apartment complexes offers the best rate? Well, you don't want to just plug in 1 here because this is in terms of months. So how many months are there in a year? Well, there's 12. So in this case, the M is equal to 12. So all you have to do is grab a calculator and plug these in to your equations and see which one gives you the cheaper final cost. So if I plug 12 into the first equation, then I get the cost is equal to 525 times 12 plus 750. So 525 times 12, that's $6,300 plus the 750. So that means in 1 year, the total cost would be $7,050. Okay, so there's the first answer. In this other apartment complex, if I do the same thing, I'd say C equals 600 times the 12 months plus the $200 maintenance fee. So 600 times 12, that's $7,200 plus the $200 fee. So if I add those together, I get that the total cost for this year is $7,400 or $7,400. So which one has the better deal? Well, the apartment complex number 1. So which one has a better rate? Our apartment complex number 1, because it's going to be cheaper in a year.